Hello everyone, today we'll talk about the solution to the problem walking robot simulation. We don't have to do any optimizations here, so this is a straightforward implementation problem, and we'll focus on that implementation. First of all, we're going to need a way to check if a given position has an obstacle. Those obstacles are given as a list of pairs, and of course checking for membership in a list of pairs is slow. It's proportional to the length of that list, especially if we expect most of the obstacles not to be on that list. Then we have to look at everything on the list, so that is not very good. We could sort this list and then have a logarithmic time to binary search on that list, but an easier way is just to create a set, because in that set then membership checking is in general constant time. And of course, since this is a list, we cannot have a list whose elements are a set whose elements are lists, because lists are mutable, tuples are immutable. To convert everything from list to tuple in obstacles, we just map tuple over obstacles. So now our obstacles is a set, and we can check easily if a pair is in obstacles. We're going to do that on line 23. Then we also need to know the directions in which we can go, and these are the directions following turning right. So this is north, then east, and so on. So this just has to be adjusted to the problem. The current direction is the 0th index. Our current direction will be 0, 1, 2, or 3. And we'll be increasing or decreasing it by 1 whenever we turn. Our best score, as well as our starting row and column, is 0, and the score of any position is the squared Euclidean distance. Of course, if you're unfamiliar why it's a squared Euclidean distance, it's because the squared Euclidean distance and the normal Euclidean distance behave the same, at least if you sort points by their distance or their squared distance, you get the same thing. And it's easier because a squared Euclidean distance is always an integer. Well, because of course it's the squared Euclidean distance is just row squared plus column squared, and a normal Euclidean distance you would also have to take the square root, in which case it might stop being an integer. And now we go through all the commands. The turn-in commands, -2 and -1, just subtract 1 or add 1 to the current direction. And whenever we want to move, we want to make sure that our current direction is between 0 and 3 inclusive, so we just take it modulo 4, and we take it step by step. We look at the next position we'll be getting into. This is where we use those DRs and DCs arrays. We just add it to R and C, and if it's an obstacle we cannot do anything, we break, otherwise this is a new position. So we calculate the score of that position, maybe it's the best score. After going through all the commands, we just return the best score.